So, welcome to today's webinar with Edgeless Systems. My name is Daniela Bentrup. I'm Senior Developer Marketing Manager at Edgeless. If you have any questions during the session, please feel free to put them in the staged chat window and we'll save some time at the end to answer them for you. We are recording this event and we'll share the video in the next days. In this webinar, we'll present EdgelessDB, taking database security to the next level with confidential computing. And with that, I'd like to introduce Felix Schuster, CEO at Edgeless Systems. Felix, I pass it to you.
Yeah, thank you, Daniela, and thank you everyone for joining. It's a pleasure to introduce EdgelessDB to you. So this is something that we have been working on for almost 2 years. And as you may know, we are a company working on scalable and confidential stack for cloud computing. And let me just share my screen and give you an introduction to us and what we do, and of course to EdgelessDB. Okay. Here we are. All right, so today's topic is EdgelessDB, the first database for confidential computing. And just to get you excited about this, before we dive into the details, on the right-hand side, you can see all green check marks, and this is what a confidential database like EdgelessDB can give you. So it gives you data encryption on disk, gives you runtime protection for your keys, it gives you runtime protection for data and for code, and it doesn't require you to buy new hardware in case you already have Intel SGX hardware. And it also gives you something that we call verifiability. And this is a super exciting feature, and this is something that I will be digging into in the next 30 minutes. And in comparison, on the left-hand side, you can see a normal database can at most give you encryption on disk in some ways, and it doesn't require extra hardware. And the state of the art currently is that you use a normal database together with what is called an HSM, hardware security module. And this obviously requires you to buy extra hardware, but in return, you get runtime protection for your keys and some extended functionality for your data encryption on disk. All right, so this is the background and the motivation why we need something like EdgelessDB. And before we proceed with the details, just a couple of sentences about myself and our company. So as Daniela said, I'm the CEO and co-founder of Edgeless Systems. We are a startup based in Bochum, Germany. We have roughly 12 engineers at this point, and we're trying to build an open source tool stack for confidential computing that makes confidential computing easily accessible for everyone. And we have been working on this since 2019. Before that, I was a researcher at Microsoft, working on the foundations of what is Azure confidential computing today. And we as a company, Edgeless Systems, we've released a couple of products over the last 2 years, but EdgelessDB really has always been at the center of what we do. And when we started in 2019, we already had the vision for EdgelessDB, and this has been in the making for quite some time. And so we are super excited that we were able to finally release EdgelessDB to the public last month. And of course, like everything we do, EdgelessDB is free open source. You can find it on GitHub. So please, after this presentation, please feel free to do whatever you want with the code, and we are looking very much forward to your issues, commits, and pull requests. And of course, stars if you like what you saw. But now, briefly, the agenda for today. First one is a super quick introduction to confidential computing. I already said confidential computing at least 10 times. So some of you may be wondering what it actually is about. So we'll do a quick intro to that. After that, I'm going to show you how to use EdgelessDB, how easy it is to use. Then it's going to become a bit more technical. I'm going to talk about the architecture of EdgelessDB. And finally, I'll talk about comparisons, a bit more about the comparison to existing databases, and also talk about advanced use cases. All right, and this is going to take roughly like 35 minutes. And after that, we are very much open to questions. And before we proceed, let me just quickly enable a poll that we have prepared just to understand. One second. Want to create a poll to ask you about your understanding of. There it goes. So please feel free to tell us what your understanding of confidential computing is. Yep. Okay. So super brief introduction. Confidential computing is somewhat a hype topic at this point, and the reason is that it adds two missing pieces to data security. So obviously, we already have encryption at rest. So you can encrypt your data on disk, and we have encryption in transit. So you can encrypt your data when sending it to someone, for example, into the cloud. What is missing so far is encryption during processing and verifiability. So once you've sent your data to the cloud, obviously the cloud provider needs to decrypt it, to process it, and currently you have almost no means to verify if the right things are being processed. This changes with confidential computing. It adds the two missing pieces. And so it's no surprise that there's quite some hype going on, and rightfully so. And even the mainstream media is getting excited about it. So there were a couple of Forbes articles recently. They've had it on the top 10 list for digital transformation trends for this year, next to heavy hitters like 5G. And there's also quite some interest coming from the blockchain world, because there's some interesting connections between smart contracts and confidential computing and transactions in general. All right, so from a technical perspective, confidential computing is all about running sensitive workloads in so-called enclaves. And you as a programmer, or we as a programmer, we can just go and tell, for example, modern Intel CPUs or modern AMD CPUs to create what is called an enclave for us. And this is nothing special, nothing magic. It's just another instruction in the CPU's architecture, instruction set architecture. And so once we have this enclave, it has some very interesting properties. And we can load arbitrary code and data into this enclave. And there are three defining properties for the enclave. First one is isolation. So enclaves are strongly isolated from the rest of the system, even stronger than virtual machines. So in the case of Intel SGX, which is the most prominent implementation of enclaves, no other system component other than CPU can look inside an enclave. So no operating system, no hypervisor, no other apps, no other hardware component. The CPU really takes care of isolating the enclave from all of that. And so you don't need to worry about any attackers in your stack. Like, you don't need to worry about rootkits in your operating system, or malicious administrators, or even physical attackers. For example, like intruders into your data center. And the second very important property is runtime encryption. So the CPU takes care to encrypt everything in RAM, or keep everything encrypted in RAM while it's processing that enclave. And the CPU will only take tiny bits and pieces out of the memory at any given time and decode it inside its caches and registers. And now the third important feature is verifiability. And verifiability enables us to verify that there's really an enclave running on a genuine Intel SGX CPU, for instance, maybe in Azure or at a different cloud provider, and verify that this enclave is running a specific piece of software, for example, EdgelessDB, and that this specific piece of software was configured in certain ways. So we can establish deep trust in an enclave by knowing that it's isolated, always encrypted, and that it really is running the code it is supposed to run. And many believe, including us, that confidential computing will be a cornerstone of the cloud of the future, because it really allows you to use the cloud like on-prem and remove the cloud provider from your trusted computing base in a large extent. And almost all relevant cloud providers these days have confidential computing offerings. And we are in this webinar, we are focusing on Azure and Intel SGX. So EdgelessDB currently only runs on Intel SGX. Intel SGX is available in the latest generation of Intel Xeon processors. And these are, for example, available in Azure, but they are also available in other clouds like Alibaba Cloud. Unfortunately, they are not yet available or enabled in the Google Cloud or in AWS, but we're working on bringing EdgelessDB to those clouds as well. Okay, in general, use cases for confidential computing. We see two big use cases. First one is making existing apps more secure, and thus allowing people to move more data to the cloud. This is super exciting, and it will really allow the cloud to get to the next step. The second very interesting aspect is that it allows one to create new apps with built-in privacy. And this is something that builds on the verifiability aspect. And I'll talk a bit about that later in the presentation. For EdgelessDB, we have the same two use cases. So you can, by just replacing your existing database, you can make your database deployment more secure, right? So say you have MySQL running there, you can replace that with EdgelessDB and be more secure, and maybe then you can even move it to the cloud, which you possibly couldn't do before. And EdgelessDB can also be used to implement very interesting applications. Okay, so EdgelessDB in a nutshell. Everything always encrypted, everything very verifiable. So the whole database runs entirely inside an enclave. And the data that's stored in EdgelessDB never touches the outside memory or disk in plain text. It is a full SQL database. So it's 100% compatible with MySQL. So if you're running an existing deployment, or if you have existing software that is compatible with MySQL, then you will also be compatible with EdgelessDB. And it is built with proven open source software components. So we didn't reinvent the wheel. So we took bits and pieces of proven software components, stick them together, modified them, optimized them for the enclave, and added an encryption layer and some confidential computing features. And then we put that into an enclave, and we run it there, and through that we get great stability and compatibility. And finally, it's very easy to deploy and to integrate. And I'll give you a demo in a second. And in essence, what you need to do to use EdgelessDB, it's very simple. So 4 steps, or 2.5 steps, 3.5 steps. So first one is you run the Docker image. This is a single command. Second one is you create what we call a manifest. You set that manifest, and this is something that is specific for confidential computing, and then you connect your clients. And if anything bad happens, if your system crashes or your data center burns down, then there's a 4th step, and that is recovery. Because everything EdgelessDB is always encrypted, we need to have special mechanisms to recover from disaster. And steps 2 and 4, they are new. So if you have been using a normal SQL database so far, you would typically do steps 1 and 3. With EdgelessDB, you get the additional steps 2 and 4, but they are quite easy to handle. And let me give you a demo. And I need to switch windows for that. Okay. Let's walk through creating a EdgelessDB instance and using it. Left-hand side, you can see Visual Studio Code window that is connected to an Azure VM that is Intel SGX enabled. Right-hand side, you can obviously see our website. Here, let me just browse quickly to the EdgelessDB documentation. And what I'm going to do now is I'm going to walk you through the quick start guide. Okay, so it's really super simple. First step is to run the Docker image from GitHub. So it's pulling the image and it's just starting the Enclave. And yeah, so we now have a running instance of EdgelessDB inside an Enclave in Azure, and it's saying that it's waiting for a manifest. Okay, so let's give it a manifest. And for that, we first need to create a couple of keys and certificates. And if you have ever used TLS and created some keys, you'll probably be familiar with the OpenSSL tool. Here we are creating a certificate for a user called root user, and that certificate is issued by some root CA. And in order to create the manifest, we need to get rid of the new lines in the CA certificate. And now we are good to create the manifest. Let me save that as manifest.json. And copy this over. Okay, so what do we have here? We have two entries in the manifest. First one is the SQL entry, and here you can essentially insert any SQL statement, and this is how the database gets initialized. So with a normal database, you would log in and create some users, create some tables, and with EdgelessDB, you define this initialization in the initial manifest. And the reason why we do this is so that you can later on verify that you're talking to a database that was indeed initialized in a certain way and that only certain users can access this database. So in this case, we are just creating a root user called root user, and we grant them access to essentially everything. And the second entry here is called CA, and this is the CA with respect to which all the users in the SQL statement are authenticated. And here we're just going to copy paste the CA certificate from the previous step. All right, and now we have our own manifest. In a production environment, you would also want to add a section called recover, and in that section, you would add the public key of a party who should be able to recover the database in case of disaster. But you can find that in the documentation, but we're going to leave that out for now. All right. So manifest is done. What's next? Next, we need to make sure that EdgelessDB is indeed running inside an Enclave and that we are talking to the right version of the software. So first step is here to get some specification of the software. Let me open that file. It's again a JSON file, super simple content. Essentially, these are the properties that uniquely identify a piece of Enclave software. And in this case, we're using the signer ID, which is essentially the fingerprint of our company's signing key. And this, if you are familiar with SGX jargon, this corresponds to the MR signer field in the Intel SGX attestation. We could also use the MR Enclave, which is the hash of the overall Enclave here to identify the software, but for simplicity, we're using the signer ID. Product ID here is 16. 16 is our internal product ID for EdgelessDB,
and security version is currently at 1. And this triplet uniquely identifies our current EdgelessDB deployment. Okay, so we have that, and now we're going to verify if our EdgelessDB instance that we just started is adhering to this specification, and if it is indeed running inside an SGX enclave. So we use a tool called Error, and I installed Error before the session on my machine. It's also an open source tool from our company, and what Error now does is it will connect to EdgelessDB via a REST API, and it will engage in an attestation protocol with EdgelessDB, and if it succeeds, it will get EdgelessDB's self-signed TLS certificate. And based on that, we can then establish secure connections to EdgelessDB, and we know precisely that we're talking to the intended version of EdgelessDB. Okay. So we got that. Root certificate written to EdgelessDB. Don't worry about the error. This has something to do with logging. But we now have a verified and attested self-signed certificate for EdgelessDB. We know that it's running inside a good Intel SGX enclave and that it complies with these values up here. Okay, so now we can set up secure connections to EdgelessDB. And this is what we're going to do now. We're going to use the well-known curl command to send over the manifest that we created earlier. And yep, so curl sent over the manifest, and now we can check over here. Okay, EdgelessDB got the manifest, and now we should be good to use it. And what remains is we can now use our existing or unmodified MySQL client to connect to EdgelessDB using the TLS credentials that we created in the previous step and that we specified in the manifest. So just copied over the command, and yeah, I'm connected, and I can just use it as normal. Like I can create a database, hello, and that should work. Yeah, use hello, and I can essentially use it as a normal SQL database. I can connect any client. I could now connect a GUI client, or I could connect a Java app, and they could all verify just by using the edb.pem as the foundation for the TLS connection. They could make sure that they're talking to the right EdgelessDB instance running inside an enclave.
So we walked through all the steps. You now know how to set up EdgelessDB, and it will just work with your existing clients. We saw the demo, and now let's talk a bit about the architecture and understand what makes EdgelessDB special. So we start with Intel SGX. So Intel SGX gives us this enclave and gives us the strongest enclave available in the market. And inside SGX, we use an open source component that's called Open Enclave. And Open Enclave was originally developed by Microsoft. When I was still a Microsoft employee, I also wrote a couple of lines of that. And by now, Open Enclave is being maintained by the Linux Foundation and by the Confidential Computing Consortium. So it's sort of an industry standard. On top of Open Enclave, we run two well-known and proven open source components. One being MariaDB. MariaDB, as you may know, is an open source variant of MySQL, and the other one being Roxdb. So we use the SQL front end from MariaDB, and we use the thing called Roxdb as a storage backend. So this is a modified version of MariaDB. And I'll talk a bit about Roxdb in a second, and the reason for us using it. And Roxdb takes care of storing all the data in the database. And it obviously it writes data to disk, because every time we exceed our buffers inside the enclave, Roxdb swaps out data to the disk, and it takes care of encrypting and decrypting everything as data goes in and out. VerifiabilityDB takes care of all the front end stuff. So if you're connecting through TLS with your database, then you will be talking to the VerifiabilityDB front end. And the TLS channel, as I said, terminates inside the enclave. So there's a secure channel directly from your client into the enclave. And then there is another component that we developed from scratch, and that is the confidential computing specific front end. And this front end essentially implements a REST API that provides all the confidential computing specific functionality to the outside world. And this can also be talked to over a tested TLS. So a tested TLS means that you use a TLS connection in which the certificate of the server is attested through Intel SGX. And this is what we did in the demo with the edb.pem. Okay, so a quick look at the REST API. Just a couple of functions. The first one is quote, and the error tool that I just showed to you uses that API. You can use it by manually as well, but error is probably the simplest solution. The quote endpoint gives you an SGX quote for the database's self-signed certificate, and you can use that for remote attestation. The manifest endpoint gives you a way to set the manifest. We also did that in the demo using the curl tool. Signature gets you a signature for the manifest, so you can verify that a certain database was indeed initialized with a certain manifest. And recover allows you to update a recovery key to start the recovery process. And to do that, you need to define a recovery key inside your manifest. And that is, again, a public key. And EdgelessDB will, if you define a recovery key inside your manifest, EdgelessDB will output a recovery key that is encrypted for this certain public key. And if now disaster happens, what you need to do is you need to decrypt that key and send it over to your EdgelessDB instance that you want to recover. All right, let's take a closer look at what makes EdgelessDB special from a security perspective, and take a look at Roxdb. So we use a modif. So Roxdb originally, is being developed at Facebook, and there are also versions of MySQL out there that use Roxdb as a storage backend. And we looked carefully at the different storage backends, and we decided to go with Roxdb because it has some very nice properties. It is high performance, and it has a certain structure of writing files to the outside world that makes it very appealing in our enclave context. And I don't want to dig too deep into the details here. If you're interested in the details, we'll have a blog post up this week or next week where we really go into the juicy details. But just for you to just understand the basic reasoning here is Roxdb writes or flushes database entries to the untrusted world using a format called SST. And SST files, they are sorted and they are append only. So they are written once and they are read only. And this makes it very easy for us to efficiently encrypt them. And in addition to these SST files, there are a couple of other files. There's a write-ahead log, which we also encrypt, and a manifest file. And these three types of files, they make up the state of Roxdb. And And because how these files are structured makes it very cost efficient for us to encrypt them and protect them at runtime. And the overall security property that we get out of this construction is that we have integrity and confidentiality for all database state at all times. And this is a very important and strong statement, because what this means is we protect all the files and all the data that the database has at a certain point in time from modifications. So an attacker, maybe a rootkit, maybe some malware, cannot just go and swap a file, delete a file, or roll back a file. This will all be detected. The only thing that the attacker can do is they can roll the entire database back to a previous point in time if they can exchange all the files. But they cannot just modify certain parts of the state. And this is a very, very strong property. And this is something that is unique for EdgelessDB. Okay, so talking about the benefits of our custom Roxdb. So next to security, we have performance. And you may have heard that software can be slow when it is being run inside enclaves. So with EdgelessDB, we really wanted to minimize the overhead, and we are still in the middle of optimizing that. But even at this version, we already have some very good performance. So in the industry standard benchmark TPCC, we get throughput that has around 29% overhead compared to baseline. So we get to 600 transactions per second compared to 780 or so, and we get to 17,000 queries compared to 22,000 queries per second. And this is super fast, or well within the tolerance of most applications. And actually, in many benchmarks, EdgelessDB running inside an SGX enclave can be faster than normal MariaDB running outside an SGX enclave. Here in these benchmarks, we try to compare to be as fair as possible and compare apples with apples. So we compared EdgelessDB running inside an enclave to MariaDB with a certain version of Roxdb running outside the enclave. So we say that the performance of EdgelessDB is very practical and it's ready for production use, but we are confident that we can get the overhead down to single-digit percentage. And one important thing we should note here as well is, of course, enclaves used to be limited in size. So you may have heard that in the past, there were only a couple of 100 megabytes of enclave space. This has changed with the latest generation of Intel CPUs. But regardless on which enclave you run EdgelessDB, you will always get unlimited storage. Right? So EdgelessDB is not bound by the size of the enclave. The larger your enclave space, the faster EdgelessDB will go, but it can always compensate for limitations in the available enclave space. Okay, so comparison to other approaches. We had this table in the beginning. Just to recall, we have all these green check marks on the right-hand side, and maybe importantly, we have the verifiability and manifest feature. And yeah, this is what I described in the last couple of slides, that we have this manifest, we have the verification aspect. You can send over the manifest, verify that everything is in a good shape. And we believe that this is a super important, very powerful property. So but this is like comparing the current state of the art to the last generation state of the art. So there are, of course, there are one or two other approaches where people use SQL servers or databases with enclaves, and maybe the most prominent of them being SQL Server from Microsoft. And there are two versions of SQL Server. The SQL Server always encrypted with enclaves and without enclaves. And if you use SQL Server always encrypted, you will encrypt your data on the client before sending it over to the server. And this way, your data stays always encrypted, but the server is also severely limited in what it can do. So there are only certain operations SQL Server without enclaves can do in always encrypted mode. So you can, for example, just compare certain values, but you cannot actually work with the data. So to address this limitation, SQL Server has been supporting enclaves for some time now. But the fundamental difference to EdgelessDB is that SQL Server, always encrypted with enclaves, only runs a certain part of SQL Server inside enclaves. And crucially, the database engine is still running outside the enclave. And thus, it's not possible to verify the overall state of the enclave. And attackers still have different angles to interfere with your database and potentially intercept data. And this is also limited in functionality to some extent. There are certain, if you are an SGX expert, you may be aware that there are great frameworks like Graphene or Oclum out there who make it easy to port applications to the enclave. And one possible approach would be to just take an existing SQL database and run it in Graphene or in Oclum. This may work or it may not work. The problem will be that things will be less optimized, so you will see higher performance impacts. And also, you will need to carefully reason about how these frameworks actually encrypt your data on disk to understand what kind of protection you get. And you will probably not get overall integrity for your entire database state. Yeah, so advanced use cases. And this is the last thing I wanted to talk about. Let me just briefly check here. I think I need to copy something over. Okay, there we are. All right. So that slide was still in the wrong slide deck. So advanced use cases. EdgelessDB can now, of course, be used standalone, but it can also be at the center of interesting new applications. And if you recall, in the beginning, we said there are two interesting use cases for confidential computing. First one being making things more secure, and the second one being creating new privacy-preserving and verifiable applications. And with EdgelessDB, you can do both, and you can build very interesting applications. And we have been doing this with our partners. For example, at Bosch, we've built an end-to-end privacy-preserving analytics backend for customer data. And there are many other similar possible applications out there. And the abstract architecture of all of these applications is on the left-hand side, you have some data producers. They're producing some sensitive data. On the right-hand side, you have some analytics consumers. And now the right-hand side wants to learn something from the data, but the left-hand side doesn't want to give away that data. So with EdgelessDB and confidential computing and the other tooling we're building at Edgeless Systems, for example, Marble, you can now build end-to-end verifiable systems that can be used to address both of these needs. So the left-hand side doesn't want to give away the data, the right-hand side wants to get some insights about that data. And how this works is you set up a microservice style architecture, left-hand side, you create a front end for the data to get in, you use EdgelessDB to store the data, potentially also to analyze the data using SQL queries. And then on the right-hand side, you have some analytics component, maybe a machine learning component, or maybe just something like like a small app that runs queries on the database. And now with the help of the manifest in EdgelessDB, you can define that only a certain front end and only a certain analytics backend can talk to the database in certain ways. And this is what makes this manifest construct that we have so powerful, because it allows you to put in stone certain aspects of your systems and use this JSON file to define what can be done with the database and whatnot. And we are sure that there are almost endless interesting applications out there. And if you have something interesting in mind, please get in touch and let us know. And we are always super interested in learning about use cases. All right. Okay. Sorry, the the summary slide is kind of empty, but just to wrap up, I gave an introduction to EdgelessDB, and I showed you how it can be easily set up and used, and I highlighted the different benefits. So you get all of the green check marks we saw: data encryption at runtime, code protection at runtime, verifiability, and very strong security guarantees overall, and also the ability to build end-to-end confidential apps using EdgelessDB at the core. And that marks the end of my talk. As I said, we're very interested in learning about use cases, so please don't hesitate to get in touch. And please go to our website to engage. We have a Discord for you to ask questions. Everything is on GitHub. Feel free to open up issues if you are stuck. Feel free to leave a star. And with that, I'm open to questions. And let's see if we have any questions. If you have questions, please feel free to just write in the chat. Hey, Daniela.
Hi. Yeah, there is one question coming in right now. Would it be possible to bring existing SQL DB into EDB?
I think the question is probably if you can migrate. Yeah. We did that once. It depends on what kind of SQL DB you want to load. There are certain tools if you have an existing MySQL database, you can use existing tools to migrate that to EdgelessDB. I'm pretty sure that will work, and we tried that out in the past. Yeah, and if you have SQL Server or some Oracle database, then potentially there are also tools out there, and those should work as well. And I think we ported a SQL Server database to EdgelessDB in the past, and that worked. All right. Then, if you don't have anything else, thank you for your attention. Thank you for stopping by, and let's keep in touch. Have a good one.